In this video, we're going to get some practice creating a number line chart for a polynomial function and then using that number line chart to graph the polynomial function. Okay, so here might be the instructions. It could just be graph, but I'll say graph using end behavior, zeros, and multiplicities. Okay, graph using end behavior, zeros, and multiplicities. And the function we're going to look at is f of x equals negative times x plus 3 to the fourth times x minus 4 times x plus 1 squared. Okay, so we need to create a number line chart or a sign chart for this function first. So this function is factored, which helps us get the zeros and their multiplicities. So see if you can get the zeros and multiplicities here, and then come back and check your answers. So the zeros are negative 3 multiplicity 4, positive 4 multiplicity 1, and negative 1 multiplicity 2. Those are all x values. Okay, so we've got our zeros and multiplicities. We need the end behavior. So for the end behavior, you're going to need to know your leading term. So see if you can identify the leading term and then draw your end behavior. When you think you've got them, come back and check your answers. So the leading term is negative x to the 7th, which means that your left end goes up and your right end goes down. Okay. Now we'll create our number line chart. So our x's will be on the number line, our y's will be above the number line, and we need to cut our number line at the zeros. So negative 3, negative 1, 4. We might as well list the multiplicities. Multiplicity 4, multiplicity 2, multiplicity 1. We want to determine the y values at each of the zeros. So plug these x values into the function to calculate the y values. Come back and check your answers. You should get 0 for each of these y values. The next thing is use your end behavior to determine the y values on the ends of your number line chart. So pause your video and see if you can determine those. You should get plus on the left end and minus on the right end. Now use your multiplicities to determine if the signs are same or different over each of the zeros, and go ahead and determine the signs for the middle two intervals using your multiplicities, and then come back and check those answers. You should get a positive y value here, and you should get a positive y value here. Okay? So that's our complete number line sign chart. Now we need to translate that to a graph. Okay, so we need to set up our x-axis and our y-axis. So here's our x-axis. We're going to mark negative 1, negative 3, positive 4. And our y-axis would be somewhere like right there. It's at 0, right? We don't notice I'm not labeling 0 because 0 is not one of the cuts on our number line chart. So I'm not interested in what happens at 0. Okay, so the first thing we want to do is graph the behavior at each of the zeros. So in other words, what does it mean from our number line chart when it says that when x is negative 3, y is 0? And the same for the other two cuts, the other two zeros on the number line chart. Go ahead and see if you can graph what that means, and then come back and check your answers. What you should have gotten is you should end up with the points -3, 0, -1, 0, and 4, 0. You should get x-intercepts there. Maybe I said -4, 0. I meant +4, 0. Okay? So you get those 3 points. Now what you want to do is go in and graph your end behaviors. Okay? So see if you can use your end behaviors to graph what happens on the left end and the right end of this graph. Come back and check your answers. Okay, on the left end you should get something like this, and on the right end you should get something like this. Okay? Alright, now what we're going to do is graph the behavior in between the ends, all the stuff in the middle. So see if you can determine what it means between -3 and -1 if we say the y values are positive, and between -1 and +4 when we say the y values are positive, and try to graph that. When you're done, come back and check your final answer. So from -3 to -1, it should smoothly come back up above the x-axis, and from -1 to 4 it should smoothly come back up and down to the x-axis. So your graph should look something like this. Make sure you have no sharp points. Polynomials can't have any sharp points. And it doesn't matter how high you go above the x-axis here. We're not interested in that part. We're getting a rough sketch of the graph. But if you wanted more precision, you could always plug in x values and calculate the y values using the function equation up here to get more precision. In all honesty, they're probably very large y values because of the exponents in the function. But this should be your final graph of the original function listed here.